Hi, everybody. It's a great pleasure to welcome here Simon Roessig from the University of York. And I'm talking on behalf of the ISCA Special Interest Group on Speech Prosody. And I also thank our technicians, Victor, Leonardo, and Carlos for the work, and my student Gustavo Silveira for handling the question at the end of the presentation. Um, Simon Roessig is a lecturer in the Department of Language and Language Sciences at the University of York, working in laboratory technology and phonetics. He uses a combination of empirical and computational methods to investigate various aspects of speech. The main theme of his research is how prosody, especially intonation, shapes communication. His research takes the complexity and multidimensionality of speech into account. One of his primary goals is to contribute to a better understanding of characters and gradients in speech. By combining science and methods from phonology and phonetics, he sees in his work the intersection of the humanities and the natural sciences. His focus is particularly well articulated on dynamic systems, and more recently he has started to investigate multimodal aspects of moving beyond acoustics and articulation. Thank you so much for your willingness, Simon, and have a wonderful lecture. Thank you.
Thank you very much for inviting me, and also thank you very much for this very kind introduction. So my sound is all right. Everybody can hear me. Yeah.
Yes.
So I go ahead. Thank you. Okay. So when we look at the placement of the nuclear pitch accent in a sentence in English, broad focus and narrow focus constructions can be quite similar. In these examples shown here, the nuclear accent is on the same word, car. In both cases, car is part of the focus, but in the broad focus case, everything else is also part of the focus, of course. Well, we know that there are differences in the nuclear accent realization or type between a broad focus and a narrow focus. Based on prior research on English, we can expect car to be realized more prominently in the case of narrow focus. But what happens in the prenuclear domain, the part before the nuclear accents? Are there differences in this region? This is going to be one of the topics of this talk. Likewise, research has shown that when we compare different types of narrow focus, we might find differences in the nuclear domain or in the nuclear accent. For example, while non-corrective narrow focus, as shown on the last slide, already has some extra prominence on the focused word, a corrective narrow focus will have even more emphasis on the word. And again, the question is, what happens in the prenuclear domain, which in these two cases is also prefocal? So in this presentation, we'll be looking at the following questions. First, what does it mean for the prenuclear region to be part of the focus, to be included in the focus? And this is going to be the comparison of prenuclear prominence or prenuclear prosody in broad focus versus prenuclear prosody before a non-corrective narrow focus. And if the prenuclear part is also prefocal, that is, if it precedes a narrow focus, what is the effect of the following narrow focus type? And this is going to be the comparison of prenuclear prosody before non-corrective narrow focus to prenuclear prosody before corrective focus. So an important question to start here is, what do we know about the role of the prenuclear region? Well, it's probably safe to say that the status of prenuclear prominences is somewhat less clear than that of nuclear prominence. Some authors have argued that prenuclear accents are sort of optional or ornamental, and that they don't play such an important role for the marking of information structure. And others have acknowledged that it is in general much harder for linguists to describe prenuclear accents. So we get lower intertranscriber agreements when it comes to those prenuclear accents. And this is consistent with the observation that English-speaking adults seem to rely more on later parts of an intonation contour in perceptual learning, while younger children actually focus also on earlier parts of the contour. So in general, our picture of the prenuclear part is to some extent blurry. On the other hand, we have evidence from a variety of languages that indicates that prefocal words are less prominent compared to the same words in broad focus. Let's look at an illustration of this finding. Let's say we have a somewhat abstract scale of prominence, which is shown here on the y-axis. We will find that the prenuclear part of an utterance is realized less prominently when it occurs prefocally compared to the broad focus case. But what about prenuclear and prefocal parts before different kinds of narrow focus or different types of narrow focus? The data of Baumann et al. 2007 for German show fewer prenuclear accents before a corrective narrow focus than before a non-corrective narrow focus. So this finding means there is a smaller or lower probability of getting a pitch accent in the prefocal domain. So back to our schema or our diagram here. This means we may get less prominence in the prenuclear prefocal stretch before a corrective focus compared to a non-corrective focus, and more prominence in the nuclear domain. But we don't really have a lot of data about this pair of focus types at least for the prenuclear domain. So we don't really know a lot about these two types. So in the speech material, which I'm going to look at in this presentation, there's going to be one word that is always prenuclear. It's labeled word A here. And then there's another word that is always nuclear, labeled word B here. And these two words occur in three different focus conditions. First, with both words in broad focus. Second, with word A before a non-corrective narrow focus. So word A is prefocal here. And then B is going to be that non-corrective narrow focus. And then third, with word A before a corrective narrow focus. And word B is going to be that corrective narrow focus. The target sentence is a German target sentence. Hat den word A auf den word B gelegt. He put the word A on the word B. And of course, word A and word B are just placeholders here. In the slot of word A, we have 10 different words for tools: hammer, saw, drill. And they're German, of course: Hammer, Säge, Bohrer, and so on. And in the slot of word B, we have 20 different German sounding pseudo words. So they sound German, but they are made up: Nane, Bome, Bale, and so on. And the target words in both slots are disyllabic, and they have stress on the first syllable. So there's quite some similarity between those two words. Now, each focus condition is triggered or elicited with a different question, as shown in the next examples. So for broad focus, this pair was used. The question was, was hat gemacht? What did he do? Hat den Hammer auf die Vose gelegt. He put the hammer on the Vose. And then the narrow focus sentence, the non-corrective narrow focus sentence, was triggered by, wo hat den Hammer hingelegt? Where did he put the hammer? Hat den Hammer auf die Vose gelegt. And then finally, the corrective narrow focus sentence is triggered by, hat den Hammer auf die Maße gelegt? Did he put the hammer on the Maße? Where Maße here stands for some competitor, and that changes all the time. And then the answer is, hat den Hammer auf die Vose gelegt. He put the hammer on the Vose. Overall, 27 native speakers of German were recorded, and from those recordings, all the utterances with an internal phrase boundary were excluded. So we know that the accent on word A is indeed prenuclear, and the accent on word B is indeed nuclear. This can be very important because the definition of the nuclear accent often makes reference to prosodic phrases. And so by ensuring that they are in the same prosodic unit or prosodic phrase, we know, okay, when we talk about prenuclear, we're actually talking about prenuclear. And when we talk about nuclear, it's actually what we define as nuclear. The total number of productions that are analyzed here is slightly below 1,500. And very importantly, all F0 values that I will present are measured relative to the speaker mean of an L- % boundary tone, a low boundary tone. So for each speaker, we have a mean of 0 for their productions of the low boundary tone. There's always a low boundary tone at the end of each utterance. And we use this value as a baseline for speaker normalization. All right, as a first approximation to the data, we'll look at some time normalized F0 contours. So here we see all the time normalized F0 points in the broad focus sentence, where both the prenuclear and nuclear target word are in broad focus. And on the x-axis, we have time, normalized time. On the y-axis, we have F0 in semitones. And the white line that you see here through the scatter plot is an average F0 contour. Now here we see the same plot for the non-corrective narrow focus sentence, where the nuclear target word is in narrow focus and the prenuclear target word is prefocal. And finally, here is the plot for the corrective narrow focus sentence, where again, the nuclear target word is in focus, this time corrective focus, and the prenuclear target word is prefocal. Well, what we see here is that there is actually a lot of similarity between those contours, but the size of the peaks seem to be somewhat different. And so in the next part, we will zoom in on the prenuclear and nuclear words and look at them in more detail. So we look at the average contour now in more detail, and we sort of start from the center of the last slide. So we look at the non-corrective narrow focus sentence first. On the left, we have in this case, it's before the non-corrective narrow focus. And on the right, we have the nuclear word, the word that is in the narrow focus. And now we add the broad focus sentence in green dotted lines, as you see here. And what we can observe is, well, if we look at the nuclear domain first, the right side, we have sort of a higher F0 peak for narrow focus. But there's also something that happens in the prenuclear domain on the left side. Here F0 is lower before the non-corrective narrow focus. What we also see is that in the nuclear word, we find both an adjusted start and peak of the rise, whereas the difference in the rise in the prenuclear domain on the left side seems to be driven mainly by the peak alone. Okay, we go to the next comparison. We start out with the non-corrective narrow focus case again, and now we add corrective narrow focus here in red dashed lines. We see corrective focus is higher in the nuclear domain on the right side. But again, there's also a change in the prenuclear domain. Here the F0 is lower before corrective focus. And again, in the nuclear word, we find both an adjusted start and peak of the rise, whereas the difference in the rise in the prenuclear domain on the left side is driven mainly by the peak alone. Now we continue the investigation by measuring two phonetic parameters in each of the words and analyzing them. One will be the F0 maximum of the word. And again, remember, the F0 measures are in semitones relative to the low boundary tone, L- % at the end of the sentences for each speaker. And then we also consider the temporal domain and measure the duration of the stressed syllable. And the data will be analyzed with a Bayesian mixed model, where as response variable, we have each of the phonetic measurements, F0 maximum or syllable duration, and the predictor variable is the focus condition. And in addition, we have random effects for speakers and target words. So this is the setup of the analysis. We begin with the results for the F0 maxima. Again, we start with the non-corrective narrow focus case, plotted here as blue triangles. The dot itself shows the estimated mean from the regression model, and the whiskers represent the 90% credible interval. Now we add the broad focus sentence, and it's shown here in green circles. We see what we already saw in the average contrast. We have a higher F0 maximum when the prenuclear word is part of the broad focus. And we have the mirror image in the nuclear domain with a higher F0 max for the non-corrective narrow focus. And finally, we add the corrective focus case, which is shown in red squares here. And now we see that in the prenuclear domain, we get the lowest F0 maxima before corrective focus, whereas we get the highest F0 maxima in the nuclear domain, where the focus is actually located. Now, we can use the Bayesian regression model to further look at the differences between the conditions, and we can check whether the estimated distribution of a difference between two conditions is mostly greater or smaller than 0. And if we look at that distribution, we find no overlap with 0. That sort of gives us confidence in saying we have good evidence that there is really a difference here. So we have a short look at the differences in the next part. So first we look at prenuclear in broad focus versus prenuclear before non-corrective narrow focus. And we see the distribution is well separated from the dashed line, which represents 0. And we do the same thing for the next pair, prenuclear before non-corrective narrow focus versus prenuclear before corrective narrow focus. And we see the distribution is well separated from the dashed line, which is the 0 line. So what do we find here? To summarize our findings here for F0 maximum, there is an effect when it comes to whether the prenuclear domain is in focus versus when it's not. Prenuclear words are realized with lower F0 maxima before non-corrective narrow focus than as part of a broad focus. And there's also an effect of the following focus type on the prenuclear domain. Prenuclear words are realized with lower F0 maxima before corrective narrow focus than before non-corrective narrow focus. Now we turn to the temporal domain, to the duration of the stressed syllable of our target words. And we basically do the same thing. We start with the non-corrective narrow focus sentence again. And then we add the broad focus case in green circles. And we see the same pattern, longer durations when the prenuclear word is part of the broad focus. And the mirror image in the nuclear domain, longer durations for the non-corrective narrow focus. And now we add the corrective narrow focus, again in red squares. And we see the prenuclear words before corrective focus have the shortest syllable durations. And we have the mirror image in the nuclear domain with longest durations for corrective focus. Although, as you can see here, the step up from the non-corrective narrow focus is really small. So the difference seems even greater here in the prenuclear domain than in the nuclear domain. And again, we check the differences in terms of the posterior distributions from a regression model. First for prenuclear in broad focus versus prenuclear before non-corrective narrow focus. And we see the distribution doesn't include 0, which is the dashed line, which is good. And we do the same thing for the next pair, prenuclear before non-corrective narrow focus versus prenuclear before corrective focus. And again, we see a rather good separation from 0. To sum up our findings for the temporal domain here, prenuclear words are realized with shorter durations before non-corrective narrow focus than when they are part of the broad focus. And prenuclear words are realized with shorter durations before corrective narrow focus than before non-corrective narrow focus. So this study sort of provides further evidence that the prosody of the prenuclear part is indeed affected by whether it is in focus or not. So in using the diagram from the beginning again, we find the prenuclear part before narrow focus is less prominent, while the nuclear part is more prominent. So we have sort of a concentration of prominence here in the nuclear part. And we also see the prenuclear part is affected by the following narrow focus type. And this is particularly interesting because we have less prior research to rely on for this comparison. We find that the prefocal prenuclear part before corrective focus is realized less prominently, while the nuclear focal part is more prominent. So prominence is even concentrated more on the side of the nucleus in this case. Now, the study confirms previous results that show that, in general, the prenuclear region may play a role for information structure marking. And we may think of the relation between the prenuclear and the nuclear word as sort of inverse, where one side gains more weight and the other side loses weight. And this then leads to a tilt towards the nuclear side when we go to narrow focus and corrective focus. And additionally, or alternatively, if you will, we may interpret these present findings as an indication that, yeah, information structure or focus structure is indeed distributed across the phrase. And the marking is not only local. And this is, I think, particularly clear in the case of the two narrow focus types, because here the prefocal background is affected, although the actual information structure change is in the nuclear word or on the nuclear word. We still get an effect earlier in the sentence. Well, of course, we can see a variety of limitations. One thing that's quite obvious is that the effects are quite subtle, quite small. And this is in line with previous findings that indicate that the modulations in the prenuclear domain that are induced by information status, information structure, are rather continuous and don't seem to affect categorical accentuation or accent type choice so much. But because the effects are so subtle, so small, the question must be asked, what could be the role of these differences in perception? And this is going to be the topic of the second part of this talk. So in this part, I would like to talk about, first results of a series of perception experiments that I'm planning to run. And the results will be rather preliminary, but could be interesting to some of you in this context. So in this part, we'd like to know whether syntagmatic prominence relations between prenuclear and nuclear accents, similar to the ones found in production, actually matter in perception. And one way to investigate this is the following. When asked to identify focus structures, can listeners be influenced by the relative height of the prenuclear peak alone? So when we change the prenuclear peak in relation to the nuclear peak, does this do anything to their ratings or to their responses in terms of which focus structure a sentence has? And the spoiler here is sort of yes, probably yes, but not a lot. The effects again are quite subtle, quite small, and this is also sort of expected. But yeah, we'll talk about it in more detail. But first of all, some background to all of this. Gussenhoven, 1983, is probably one of the first experiments to look at the role of prenuclear accents in perception. And he asked the question whether a sentence with a prenuclear accent on the verb will be understood as a broad focus statement, while the lack of the prenuclear accent on the verb signals a narrow focus on the object. And he recorded two contexts, one where the sentence is in a broad focus and one where the same sentence occurs with a narrow focus on the object. And from these recordings then, he constructed 4 experimental conditions. In 2 of them, in one half of the stimuli, there was a match between the answer and the question in terms of information structure. This means that a broad focus statement occurs with a broad focus trigger question or after a broad focus trigger question. And likewise, a narrow focus statement occurs with the narrow focus trigger. So there's a match between question and answer. And then in the other half of the stimuli, questions and answers are crossed, and that creates a mismatch. This means that a narrow focus statement follows the broad focus trigger question, and vice versa, the broad focus statement follows the narrow focus trigger question. And then he asked, when presented with a match and a mismatch, are listeners able to tell which is the match and which is the mismatch? And that didn't seem to be the case. Listeners were not able to perform better than chance in this task. So apparently the presence or absence of a prenuclear accent on the verb does not really make a difference here. And this is also supported by the findings of Welby 2003. On the other hand, we have the findings of Bishop 2012, and in his beautiful experiment, he played listeners the same sentence, but with different context questions. The summary that I'm going to give here is slightly simplified, but I think the essence is preserved. So once he played them the sentence with a broad focus context, with a broad focus question, and then he played them the same sentence with a narrow focus context. And to emphasize this here, the answer sentence was always the same. So the same signal was used. The listeners actually heard the same signal in both contexts. And then they were asked to rate the prominence. Also really interesting. They show that listeners rate the object as more prominent in the narrow focus context, and they rate the verb as less prominent in the narrow focus context. And this even though the acoustic signal was always the same. So if the signal was always the same, how can we explain these findings? Well, one explanation is listeners rely on their experiences with prominence relations that they have from being exposed to real production data. So they may use their knowledge that in narrow object focus statements, the object in the nuclear position is more prominent, and the prefocal verb in the prenuclear position is less prominent. And you may remember the diagram from the beginning that I put on this slide again. And support for this comes from the study of Breen et al. 2010. Their production data shows that in narrow focus on the object, we get shorter duration, lower intensity, lower F0 on the subject and the verb, the prenuclear part, and longer duration, high intensity, high F0 on the object. And the perception results show that listeners were at least moderately successful at identifying broad and narrow focus. And narrow focus was interpreted as broad focus in only 13% of cases. So let's turn to the present study. Well, most studies have concentrated on the verb in the object. Breen et al. 2010, the study mentioned on the last slide, showed results for all parts of the sentence, including subject and object. And for this study, prominence relations between prenuclear subject and nuclear object will be the focus. And we will be looking at German. All the other studies are for English, and now this is going to be for German. So we will ask, can a change in the relation between the accents on the subject, the prenuclear accent, and the accent on the object, the nuclear accent, lead to a change in the ratings as broad or narrow focus? And the concept of this perception study is the following. We play listeners a sentence with a particular intonation contour, and then we ask them from which context does this sentence come, or which context does this sentence match. And we offer two contexts. In one, the sentence is preceded by the question, what's new? And here the statement is going to be in broad focus. And then the other context has a question that leads to a narrow focus reading of the same sentence. So broad focus, narrow focus contexts. And the intonation contour has two peaks, a prenuclear peak and a nuclear peak. And we manipulate the height of the prenuclear peak with 6 steps on an F0 continuum, ranging from 105 Hz to 155 Hz for a male speaker. And we also manipulate the height of the nuclear peak with 2 heights, 115 and 135 Hz. And then the stimuli are arranged such that all the lower nuclear peaks are in the first block, or the first half of the experiment, and all the higher nuclear peaks are in the second half of the experiment. And as base material, 4 German sentences were used. One was, Marlene will ihre Geige verschenken. Marlene wants to give away her violin. The other was, Ramona will ihre Wohnung verkaufen. Ramona wants to sell her apartment. Janina will ihren Wagen verleihen. Janina wants to lend out a car or borrow it to someone. Milena will ihren Laden vergrößern. Milena wants to expand her shop. The prenuclear peak is on the subject, more specifically on the second syllable, which is the stressed syllable. And the nuclear peak is on the object, and it's going to land here on the first syllable. 29 native speakers of German participated in the experiment with a mean age of 34 years. No subject had any hearing impairments. 21 were female, 5 male, 2 non-binary. The study was conducted as an online questionnaire, and so people carried it out with headphones at their homes. And as I said, 2 blocks. First block has the lower nuclear peaks. Second block has the slightly higher nuclear peaks. And this is the screen that the participants saw in each trial. They were asked to listen to the sentence by pressing the play button. Then they could listen to it as often as they liked. And then they were asked, which context does the sentence belong to? And then they could choose between a broad focus context and a narrow focus context. Now, these are the expectations. If we look at a diagram with the height of the prenuclear peak on the x-axis and the proportion of ratings as broad focus on the y-axis, we expect that higher prenuclear peaks lead to higher proportions of ratings as broad focus. And the height of the nuclear peak modulates this in the sense that a higher nuclear peak leads to lower proportions of broad focus responses or more narrow focus responses. In other words, higher prenuclear peaks are needed to counteract the higher degree of prominence that we have on the nuclear peak. Okay? And these are the results for block 1. Remember, block 1 is the one with the lower nuclear peak. Well, as you can see, it's not a monotonic increase, but there seems to be a certain effect, a certain upward trend here. So when we move to the right on the x-axis to higher prenuclear peaks, we do get slightly more ratings for broad focus. And now we add the second block with a higher nuclear peak. And as expected for the same heights of the prenuclear peak, we get overall fewer ratings as broad focus. Or put differently, we need more acoustic salience on the prenuclear peak when the nuclear peak is higher to get the same proportion of ratings. I modeled the data using a Bayesian logistic regression model, where fixed effects were the height of the prenuclear peak, the height of the nuclear peak, and the interaction of the two. And then the random effects are for participant and base sentence. And the model results provide evidence for a small effect of prenuclear peak height. So higher prenuclear peaks lead to more ratings as broad focus. And the model also provides evidence for a small effect of nuclear peak height. A higher nuclear peak leads to fewer ratings as broad focus. So to sum up the perception findings here, listeners seem to be able to hear something. Prenuclear peak height changes the ratings as broad focus or narrow focus, with higher prenuclear peaks leading to more ratings as broad focus. Well, the effect is quite subtle, quite small. And there is also some variation among listeners that may be quite interesting to look at in more detail. There's not enough time here today, and I haven't had a real close look at it, but it's quite interesting. And also the task was reported to be sort of difficult and felt a little unnatural, of course, to people. I mean, that wasn't totally unexpected. But almost all people I talked to reported that they found it really hard, even if they had responded in a way that was set up by the expectations. But even if they heard it, it was quite hidden for them. So in future research, I aim to employ a more natural task. It would be great to have a more fun task. It's also planned to explore the possibilities of something like mouse tracking as a window into real-time processing. Do people have expectations when they hear the prenuclear part about what's coming next? Also, more parameters than just F0 should be manipulated, because we found in production that duration plays a role. And that has the potential to make the stimuli more natural. And the consequence could also be that the task gets easier. The present results or the present study also only looked at broad focus versus a non-corrective narrow focus. And it would be interesting to see whether prenuclear information can be used to distinguish or help distinguishing the two narrow focus cases, the non-corrective narrow focus versus the corrective narrow focus, that were also part of the production study. Okay, to wrap up this entire talk. So in production, we find prominence profiles with an inverse relation between the prenuclear and the nuclear region. And these findings are, I think, in line with the model of syntagmatic tonal relations proposed by Bishop 2013. In this model, broad focus is characterized by left tonal prominence, whereas narrow focus on the object is characterized by right tonal prominence. And Bishop then outlined some of the tonal realization patterns in terms of pitch, accent choices that are shown here. So Bishop outlined some of the tonal realization patterns in terms of the pitch, accent choices. And what we see here is that the higher downstepped H stars concentrate on the left in broad focus, and they concentrate on the right in narrow focus. So the idea here reflects the findings of a prominence concentration on the side of the nucleus in narrow focus. One question, of course, would be, how can we fit in corrective narrow focus in this model that shows even more prominence concentration on the nucleus? The question is it possible to fit this in with a binary set of symbols, H and L? And then also, what I want to emphasize here, the findings of the production study suggested that the relations may be more gradient or continuous, and not only tonal, since we found differences in the temporal domain too. So the adjustments that we find here appear rather gradient and multidimensional, not just tonal and categorical. And this thought is illustrated here with the scales that can vary continuously. So you can put any amount of weight on one or the other side and then construct a certain balance or a profile. All right, so these prominence profiles in production with a prominence concentration on the nucleus are generally tested in our perception data for broad versus non-corrective narrow focus, so for the left pair here. We do get small effects that point in the following directions. Higher prenuclear peaks lead to more ratings as broad focus, and higher nuclear peaks then decrease these ratings again. So higher nuclear peaks then lead to fewer ratings as broad focus. This is what we find in perception. And that's it. I thank you for your attention, and now I look forward to your questions.
Thank you so much, Simon. It was a very, very clear presentation. It was brilliant. Thank you. Now we have time for questions. I will be waiting for Gustavo to bring the questions to the chat or read the question to Simon, please.
Okay, we haven't received any questions so far, but I think we are going to receive in a minute. It's just the time for people to write them.
Okay, thank you. I have a very small question, simple question for you. Do you think that instead of using the prenuclear F0 peak in the x-axis in your slide showing this, if you instead use the mean of the values of the prenuclear F0 curve, it would maybe have a different kind of a better increasing, so to say, because it seems to me that the important thing is the difference between the nuclear peak and what happens before, ensuring a distance between these two to help perception, so to say.
Yeah.
And probably not only the peak plays a role, but all the decreasing of because in the first slide is showing that it's not only the peak, but all the prenuclear interval seems to be lower than it was my impression. Don't you think so?
Yeah, right. I'm going back to the slide. So you're referring to the production results, right?
Yes.
So I'm going back to this slide first, which is the kind of the raw view of the data in a sense. I'm gonna try to get rid of those. Yeah. So I don't know if I fully understood your question. Are you saying that instead of using just the maximum, maybe it would be better to use some kind of time interval, maybe the entire prenuclear stretch or the entire word, and then using the that probably makes sense. I mean, it makes total sense to me. There's just one potential problem here, which I can't really fully resolve. Well, one thing is that we have the prenuclear word, which is sort of independent, which has some prominence value that may be controlled independently. And then when we move closer to the nuclear word, especially the stressed syllable, anything that happens right before it could potentially be part of the prominence, the degree of prominence on the nuclear word itself. And to make this a little more concrete, you see that in the average contours, for higher degrees of prominence, especially in this pair, it's clear. In the nuclear word, speakers seem to try to enhance the rising movement. So they have a higher peak, but also a lower value before that, and that was reported in quite a lot of studies. And so we don't really know the syllable before it could be, and even two syllables before that stressed syllable could be affected by that. And of course, that may have to do with it. It's probably not possible at all to disentangle it. But in this study, at least, I wanted to stay away a bit from the nuclear word, what I call the nuclear target word, in order to make sure I'm not getting in this region where speakers prepare this higher rise on the nuclear word. But I agree. I think there is more than just a prenuclear word that is affected. It's probably a longer stretch of speech. And this fits nicely with this idea that that a change in information structure affects basically everything in the utterance.
Yeah.
So yeah.
I think you have a question, Gustav.
Yes, the first is from Bruce McKee, I think. Okay. He said, "Hi Simon, nice presentation. Did you use a web experiment platform like LabVancit or Gorilla to run your web experiment? And would the variability in laptop recording and playback hardware?"
Yeah, thanks for this question. Yeah, I did use an online or web experiment platform, and yeah, it's really hard to tell. My assumption would be that the variability in people's responses would maybe be a little lower, because I mean, I don't really have control over what they're using. I mean, I asked them to use headphones, and I assume that most of them did, but I don't really know. And so they could be using their crappy laptop speakers and maybe not be able to hear anything. So yeah, I assume that running this in a lab would lead to less variability, and also it's much easier to record something like reaction time. So yeah, it would be great in future research to actually do this in the lab. But yeah, in the current situation, it was much easier to run it online. But yeah, thanks for this question.
Okay. Luciana Tenani says, "Thank you for the great presentation. Congratulations on the work." And Simon Tilson, "Hi Simon, are you considering any explanations for the prenuclear effects that aren't structural in nature? Do you have any thoughts on that?"
Thanks for this question. I'm struggling a little with understanding what structural means in this context. Is it information structure? Well, I must say I don't really know. My answer is probably no. I don't have any other explanations. But yeah, as I said, I don't know if I understand the question fully. Sounds like a very interesting question. Sorry.
She can clarify later if she wants.
Okay, Alessa Farinella said, "Hi, thanks for the talk. I was wondering about the perception study, since you are comparing broad and narrow focus. In the former, the prenuclear material is new, but in the latter, it's given." And she continues, "It would be really interesting to see if there is a difference between contrastive and non-contrastive narrow focus."
Yes, that's true. I totally agree. Thanks for this suggestion. I totally agree that it would be really interesting to see if there's this difference between contrastive and non-contrastive narrow focus. I mean, it's sort of in the nature of the type of the material that we're looking at, that broad is sort of all new, or most of it is new, and a narrow focus always has some part that is given and then another part that isn't. So you're right. I mean, and also definitions of focus structure vary. Some incorporate some notion of givenness and newness in their definition of focus structure. Others try to see it more as orthogonal, where we have newness or givenness on the one hand, and then we have focus on the other hand. In many cases, and this is certainly one of them, they overlap. So we have a certain dimension of givenness, and it overlaps with the dimension of focus. And yeah, contrastive versus non-contrastive narrow focus would be a way to actually overcome this, because in this case, the prefocal part would be given in both cases, and the focus part would be sort of new. Yeah, right. Yeah, thanks for this suggestion.
So the last question is by Jason Bishop. He said, great talk. Thank you so much for giving it. might it be possible to assign categorical versus gradient effects systematically to different sources? Perhaps focus size has a phonological/tonal metrical effect, and corrective focus has a gradient effect, because in the first case, it's more about syntax, semantics, whereas correction is more about pragmatics. And he also adds a additional comment. It's a very astute observation that corrective focus complicates the picture that previous work has carved out. And so this work has been a real contribution. That's it.
Thanks. Thank you very much for these questions and comments. That's a really interesting thought. Is there something that is categorically varied, and then for other parts of the system we get continuous or gradient adjustments? I don't really know. Well, I mean, now drawing on previous research that I've done or I was involved in, I think we get a lot of speaker variability here. So we've seen in other studies that some speakers in the type of experiment we're running here, of course, like to vary sort of categorically when they mark focus structure. So they like to use a certain pitch accent type, Toby pitch accent type, for one focus structure, and then another one for narrow focus, and then maybe, and then it gets a little blurry, of course, for corrective focus, while other speakers kind of stay in the same region of categorical differences, but then do those continuous adjustments. Well, and as I said, when it comes to narrow and corrective focus or contrastive focus, those categorical differences are much harder to detect, because in these two focus types, we do get a lot of H star type accents. And well, is there really a clear categorical boundary between an L plus H star and a simple H star? That's kind of blurry. But yeah, so my answer to, it's a really interesting answer, and I was just starting to think of a really interesting question, and I just start to think about it now. My short answer now would be yes. There is the potential to get more categorical differences for broad versus narrow focus, maybe, and fewer for narrow versus contrastive or corrective focus. But I guess both categorical and continuous gradient modifications are there in both oppositions or in both pairs. And I mean, if you look at the temporal domain, we can't really say this is categorical, right? So we get a continuous increase in duration, and we find this for both broad focus and versus narrow focus, and narrow focus versus corrective focus. So I think, yeah, it's continuous and categorical distinctions will be there in both cases. Yeah, that would be my answer now. But yeah, it's something I certainly would like to think about more. Yeah.
Plinio, do we still have time for more 2 questions?
Yes, 5 minutes. Yeah.
Okay. So Sam Tilson added an additional comment about his previous question. He said, I was referring more to Bishop's structure or any phrasal structure of that sort. For example, could the prenuclear suppression be an inhibitory effect of having a stronger pitch accent planted in the nuclear domain, I think, assuming that the constituent under focus can be defined syntactically, and corrective focus is a matter of expressing, interpreting intentions?
Yeah, that's a great thought. So I mean, I think I touched upon this in my answer to the first question. The idea is, I guess, or what I understand here from this question is this: are the prenuclear words and the nuclear words controlled independently, or is the effect that we see in the prenuclear domain something like sort of a preparation effect or a spillover effect where or an inhibition effect where we want to have much more prominence on the nuclear word, and in order to achieve well, or the system actually then or the result of the system is then the downplaying or the reduction of prominence in the prenuclear accent. And I think when I look at my data, I'm not sure whether I can answer this. I don't think the data really makes it possible to answer this. And I think that's a really interesting question in this context, whether, yeah, the control is independent, or there is something like an inhibition in the prenuclear domain that comes from the fact that we get more prominence in the nuclear domain. Yeah. But yeah, I don't think the data here is able to answer this. And also the perception experiments, right? Because I mean, listeners may be familiar with these patterns and then respond accordingly, but we don't really know where those patterns come from, right? Is it independent control, or is it inhibition from the stronger nuclear accent? But that's a really, really interesting thought. Yeah.
So our last question is by Luciani Tenani. Simon, is there a hypothesis about participants' performance difficulties in the perception experiment?
Yeah. Well, I mean, I guess I think that those experiments are really hard because it's a very unnatural task. Like, this is not really how we use language and speech, and so you sort of have to adjust to this really new situation. And some people are better at it, and others are worse at it. And maybe because they have done something like this before, or maybe because they are very analytical listeners, that may play a role. I didn't collect a lot of metadata, so I don't really know. This is also what makes it preliminary. And then also, I mean, an interesting thought, I'm not going to go into any detail here, is, I mean, there's this Gussenhofen-Rietveld effect that showed that actually higher prominence on a prenuclear peak can lead to the reverse pattern, where the second peak, the nuclear peak, is judged as more prominent. And I guess that speakers vary a bit too in this regard. And from what I've seen in the individual data, I also see that there's at least one speaker that seems to respond in this way, where higher F0 on the prenuclear peak leads to lower responses as broad focus. So it's the reverse pattern, which is sort of in line with the Gussenhofen-Rietveld effect. But where this comes from, I don't really know. Yeah, would be interesting to look at.
Yeah. Thank you so much for any one short question, Gustavo. It's over.
I think it's over. Santilson just made 2 short comments. I will up here.
Okay. Yeah. Okay.
Can you read to the audience, please?
Yes. Oh, you would predict a negative correlation with the inhibition account. That would be hard to predict with a structural account. That are the 2 comments.
Yeah, I see. So basically looking at the correlation on the individual utterance level between the 2 peaks. Yeah, that's a very interesting thought. Yeah, that's great.
Okay.
Yeah.
Thank you all. all the audience for listening to Simon and to be here to this as Prosody lecture. The next one would be by October 23rd, and we given by Sam Tilson, which is the one who asked the last question. Yeah, thank you so much, people, to be here, to participate in this opportunity to discuss about speech prosody. And once again, Simon, thank you so much for this brilliant and very clear presentation. I think that's the reason for so many questions, because it's easy to derive to a question, to answer, to ask a question from such a clear presentation. Thank you so much again, and have a wonderful afternoon here in Brazil for you, one so evening in Europe, and one something in the United States. Thank you so much.
Thank you.
See you later to the next talk. Bye. Thank you, Simon, again. It was brilliant.